This is a review of some of the integration from Calc 1. The first thing that you should know, of course, is the power rule for integrals, which means you increase the power by 1 and then divide by the new power. Of course, when it's an indefinite integral, meaning there's no limits on the integration, that means you're going to need a plus c. Because remember, the integral and the derivative are the opposite. If I were to take a derivative of a constant, so if I would have taken the derivative of, sorry, I don't know what's wrong, ddx of, let's say, 2, that's going to be 0. So then when we integrate, we may have had a constant that we lost. Okay, so looking at the first one, we should know the integral of e to the x, of course, it's e to the x. If the base is not e, then you have to divide by the natural log of the base. If it's 1 over x to the first power, then it's the natural log. And of course, you had all the trig ones you needed to know. If you integrate sine, you get minus cosine. And then some other ones that you had to memorize. These last two down here, you don't need to memorize, but just so that you kind of understand where they came from. If you're asked to integrate tangent, remember tangent is sine over cosine. So you're going to let u equal the cosine. Then you take the derivative as minus sine. So this would be really just minus the integral of 1 over u, which of course is the natural log of u. And the same thing with the other one. If you're integrating cotangent, you're going to think of that as cosine over sine. And you're going to let that u be your sine. And then, of course, the cosine would cancel. So those are all the integrals that you were supposed to have memorized. There was a couple more, but those are your basics. So the first one we're just going to review is the power rule. So remember, for integrals, we do not have a product rule. We do not have a quotient rule. We do not have a chain rule. So all of those things have to be simplified algebraically by either multiplying or dividing or by doing a u substitution. That's kind of the opposite of the chain rule. So looking at number 1, there is nothing being multiplied, there is nothing being divided, so it's just a straight up power rule. So each time this was x squared, so the power is going to go up to 3, and then we're going to divide by the new power. Here the power of x is 1, so we're going to add 1 to the power, divide by the new power. This was just a constant, but if you want to think of it as x to the 0th power, you add 1, so you have x, and then plus c. And of course, you don't need to simplify, but if it was a multiple choice, then of course you'd have to simplify to see the answer. This is an indefinite integral. Notice there's no limits on the integration, so that means we need the plus c. Number 2. So first thing we notice, we have a definite integral here, which means we're going to have to evaluate it at the end. So we are not going to write plus c. The other thing that we have here is a multiplication. There is no rule for integrals with multiplication. There's no product rule for integrals. So you have to distribute and simplify this. So this would be the same thing, an integral from 0 to 1, 15x cubed plus 5x squared. And then we're going to do the power rule. So you're going to go up 1, divide by the new power, up by 1, divide by the new power. This is a definite integral, so we're going to evaluate our endpoints. So we plug in the first endpoint, the top one, and then subtract in plugging in the bottom one. 3. We kind of had a division here, but what we're going to do here is just simplify that. Remember, if we have the nth root of x to the n, we can say that's x to the n over m. The other thing is if we have 1 over x to the n, we can change the sign of the fraction from top to bottom by changing the sign on the exponent. So right here, This is really a square root. This is really a first power. So this is really going to be 5, and then p to the negative 1/2. 1/2 because it had the radical, negative because it was on the bottom, plus 3p. And then we integrate. If we add 1 to 1/2, we get negative 1/2, we get 1/2. And then we're going to divide by 1/2, which is multiplied by the reciprocal 2. So you're going to multiply by 2 over 1. And then 3p squared over 2, and then plus c. And again, 14, you notice that here we have a squared. And it's not just x inside here. So we're going to have to simplify that. So remember, first thing, if you have this squared, remember that means those two things are going to be multiplied together. And you're going to distribute it out, so that integral is really going to be the integral of 4x to the 6th minus 2x cubed minus 2x cubed, so minus 4x cubed plus 1. And then we'll integrate this, and it's an indefinite integral, so we need the plus c. So 4/7 x to the 7th minus 4/4 x to the 4th plus x plus 1. I mean plus x plus c. Sorry, not plus 1. All right, number 5. So again, I don't have any multiplication or divisions, but I do have some stuff I need to clean up because I have that x on the bottom. So I'm going to go ahead and move that to the top because it's not the first power. If it was x to the first power on the bottom, remember that is the natural log. So minus x to the 7/3 plus pi. So if we integrate that, we go up by 1. So this could be x to the negative 3rd. So out in front, we're going to have negative 2/9. So x to the 10/3, and out in front, you need the reciprocal, which would be 3/10. Number 6, we are going to have to do some simplification here. We do have a division. So all I'm going to do is split the numerator because it's just dividing by x. So if I split the numerator, I'm going to have x squared over x, which is x, minus, so this one divided by this one, and then this one divided by this one, 1 over x. Remember, we don't bring the x to the top of the second one because it's to the first power, so that's your natural log. So you're going to have 1/2 x to the squared minus natural log of x evaluated from 1 to e. We plug in the top limit point minus plugging in the bottom one. We know the natural log of 1 is, of course, 0. The natural log of e is, of course, 1. So we're going to have 1/2 e squared minus, and you have a minus 1 minus 1/2, so minus 3/2. So that's going to be the same thing as e squared minus 3 over 2. Number 7, square root of 3. I know that looks kind of weird, but square root of 3 is just a constant. So all you're going to do is pick up the x and then plus 5 natural log of x plus c. 8. This right here is what's called a differential equation. It's got derivatives and non-derivatives mixed together. Remember, f prime means dy dx. So we have dy dx is equal to 2 over x plus 6 over x squared. So technically, this is a separable differential equation. So you get your dy and all your y's on one side. You get your x's and your dx on one side. Then you're going to integrate both sides. The integral of dy is, of course, y. 2 over x would be the 2 natural log of x. And of course, it's got absolute value. We just normally don't write them. And then we're integrating 6 over x squared. So remember, you're really integrating 6x to the negative 2. So when you add 1, it's going to go to negative 1, divide by that new power. So out in front, you're really going to have negative 6 over x plus c. Now we can use our initial condition to point down the particular solution. This one right here is called the general solution. It's the one with c before you use your initial condition. But we do have this initial condition, says that if we plug in 1 for x, we're going to get negative 7 for y. So negative 7 is equal to 2 natural log of 1 minus 6 over 1 plus c. We know the natural log of 1 is, of course, 0. So I'm going to get that c is negative 1. So then our solution would be 2 natural log of x minus 6 over x plus a negative 1. All right, so let's just simplify this. 1 over sine x is the same thing as cosecant x. And the integral of sine is minus cosine x. And then the integral of cosecant is minus natural log of cosecant x plus cotangent x. Now, number 10, the integral of tangent squared. Now, I know the derivative of tangent is secant squared, but I don't have tangent. I don't know the integral of tangent. I don't know the integral of tangent squared. But this would tell me that here, if I know this, that tells me the integral of secant squared is equal to tangent. And I can come up with a relationship between tangent squared and secant squared. That's a Pythagorean. We know 1 plus tangent squared x is equal to secant squared x. So this would be the same thing as secant squared x minus 1. And we know the integral of secant squared is tangent. Integral of x is 1 plus c. So the next one talks about long division and when. So before we do long division, always try to factor and cancel first. Okay, so right here, definitely cannot factor and cancel. The only thing that multiplies to a positive 3 is positive 1 and 3, or negative 1 and negative 3, and neither one are going to give you the negative 2, so it does not factor. So you do long division when you have what we're going to call a rational function, which is a polynomial over a polynomial. So when you have a rational function and the degree of the numerator, the top, is greater than or equal to the degree of the denominator, if you have that, then you will do long division. So 11. Can we factor this? So we have to do long division. The degree of the numerator is bigger than the denominator. Now, I like to leave 0 spots. It's not necessary, but it helps things possibly line up better. So how many times does x go into x cubed? In other words, x times what gives me x cubed? That would be x squared. So then we multiply this by both pieces. And just like with long division, the next thing we do is subtract. Drop down the next one, and we do the same thing. X times what gives me negative 2x squared. That'll be negative 2x. Subtract. This now gives me a positive 2x. X times what gives us 2x? So plus 2. Multiply it to both. Subtract. And I dropped a 2 and not a 3. What did I do? Right here, I should have dropped a 3. My bad. So I should have dropped a 3, then I put a 4 here, and this would be -1. So now this integral is the same thing as x squared minus 2x plus 2, which is this piece right here, plus the remainder over what you divided by. And now we can integrate this. Again, we got that rational function. Can we factor to cancel? And we absolutely can. So that would be better than doing the long division. You will end up with the exact same thing, just a lot more work. So we're left with x minus 2. And of course, integrating that. The last little thing we're going to review from Calc 1 is the second fundamental theorem of calculus, which means the derivative of the integral, and they cancel. But we got to be careful, because if we're doing the derivative of an integral, if this is not just x right here, then you have to plug it into f, that whole function, and then multiply by the derivative of it. So notice what the second fundamental says. It's got a constant here and a possible function here. So the derivative and the integral do cancel, but you're going to have to put the function in there as a composition and then multiply by the chain rule. All right, so looking at this first one. So this is in fact a right here, so we're good. This right here is just x, so we know that if we take the derivative of x, we're just going to get 1, so you're not going to see the chain rule. So this is just sine of x squared. Number 14. What's different here is we have the constant on top. So to switch the top and the bottom on the integral, you do the opposite sign. And now when we take our derivative, it cancels our integral, and nothing else happens. 15, again, we have a constant down here, but now we have a whole function up here. So our entire function is going to have to go inside x. So it's going to be 3x cubed quantity squared. Then you're going to multiply by the derivative of that, which would be 9x squared. So this would be sine of 9x to the 6th times 9x squared.